Good morning and welcome to SecTor 2017. We're here to talk about best practices to secure application containers and microservices. By background, I used to work in the US federal government, left federal service a couple years ago. So I'm going to start this conversation. Even though it says federal agency challenges from a US government perspective, it does apply broadly to both industry and government. With that, through that lens, let's talk about agility. So agencies or organizations are struggling to deliver more in a fiscally and resource-constrained environment. So by a show of hands, how many people's IT budgets are going up? Yeah, exactly. Oh, we got one person. All right, well, we want to work for him. So the reality is our budgets are not going up, but we are expected to do more in our environments. Coupled with flexibility. We have these existing IT investments. They're typically problematic to reconfigure or scale to meet these new application demands. We have users and business requirements that require new applications, but how do you modernize the existing IT investments that we have in place today? And then last but not least, transparency. It's difficult to quantify the cost of optimizing legacy infrastructure to support new applications. So through these three lenses, how do we effectively modernize our IT platform? So with that, we have to leverage a data-centric approach, right? Number one, we need to understand the information that we are entrusted to protect. If you don't understand the information you're entrusted to protect, how are you going to secure it? You need to identify and understand the value of the data in your organization. Number two, you need to decompose your data, where you take your data, break down the applications and data into building blocks. And we're going to talk a bit more about what that means, leveraging a microservices architecture and application containers. And then third, monitor your data, where you understand the risk to your data and employ continuous monitoring of your systems to identify and limit the damage an adversary has to your data. Again, if you employ a data-centric approach as opposed to securing things from an application by application or system by system approach, you now can put the appropriate safeguards and security around your information, right? Secure the data, not the device. So with that, let's talk about microservices and containers. We're going to start at a very high level. How many folks are familiar with microservices and containers? Very good, fantastic. So this level set should be kind of a very 101, and then we're going to get into a 401 of the nuts and bolts of what the actual best practices suggested would be around securing the same. So microservices, you can decompose complex applications into small independent processes communicating with each other using a language agnostic API, and that's very important. They're typically highly decoupled and modular with services organized around capabilities such as user interface or billing. And this allows for continuous integration or continuous deployment. Now, microservices are typically deployed inside containers. So containers, in a very high-level notional understanding, just like virtualization would abstract the operating system from the hardware, containers, notionally speaking, just from a understanding perspective, abstracts the applications from the operating system. You have this isolation of applications from other applications on the same OS, which then allows for cloud portability, scale up or scale out. Now, with that said, the reason we're all in here as InfoSec folks is security issues need to be evaluated and addressed in native container deployments. So, back to the level set part of our conversation. So I do wear a NIST hat as the co-chair of the NIST Cloud Security Working Group. So I'm going to put a standards kind of view on this topic. So we'll start with the NIST definition of microservices, applications, and system virtual machines, SB 800-180, which is in draft format, and we'll use the document definitions that are in there as kind of a level set for our conversation. So what are microservices per the definition? It's a basic element that results from the architectural decomposition of an application's components into loosely coupled patterns consisting of self-contained services that communicate with each other. Again, as we talked about, a standard communications protocol, well-defined APIs that are completely independent of vendors, products, or technologies. Microservices from an architectural perspective are built around capabilities as opposed to services, builds on SOA, and is typically implemented using agile techniques. And microservices, again, are typically deployed in containers. So, what are containers? So, per the definition, It's a construct designed to package and run an application or its components running in a shared operating system, right? They're, again, isolated from other containers, share the resources of the underlying OS, right? Allowing for that efficient restart, scale up, scale out of applications across clouds. So application containers typically contain microservices. So notionally speaking, just again to level set our conversation before we step into some challenges and best practices, on the left, you have a traditional virtual machine deployment. Server hardware, host OS, a type 2 hypervisor, traditional virtual machines with the full guest OS, binaries and libraries required to run your applications, right? On the right, you have same server hardware running host OS in kernel mode that has a container daemon on it, running application containers with the binaries and libraries and applications within the container itself, all orchestrated by the container daemon as running on the host OS. So notionally speaking, it typically takes, what, 2-3 minutes to restart a virtual machine and boot it up and the host OS coming up and the application coming online. Best case, right? Container coming up, fraction of a second. So efficient restart, scale up, scale out. Now, who uses containers? Google. Everything at Google runs in a container. So as of 2014, this is dated, right? They started over 2 billion containers per week. And that's years ago, right? So who else uses containers? Netflix. They use a complete microservices architecture and containers. So this is Netflix's best practices for designing a microservices architecture. So their first best practice, create a separate data store for each microservice. Again, that isolation, that portability, so that you don't have the same data store that you're pointing everything towards. Second, keep your code at a similar level of maturity. If your code is running at disparate levels of maturity, how are you going to efficiently manage the code base across the thousands or tens of thousands of microservices that make up your application, right? Number 3, do a separate build for each microservice, right? Back to that independence of microservices. They need to be independent and loosely coupled. Do separate builds for each one. 4, deploy your microservices into containers. Back to that efficient restart, scale up, scale out deployment. And then if they're all running in containers, you can now treat your servers as a stateless architecture, where you're no longer worried about what happens to the underlying host OS if it were compromised in a true stateless architecture, because you can destroy that server and restart on something else. Now, with that said, there are best practices and challenges that we are going to discuss. Now, so container security challenges. What are the problems, right? Well, with containers, you have an increased attack surface, right? Containers are far more complex than VMs, as I just previously mentioned. A single application can consist of thousands or even tens of thousands of microservices. So from an architectural challenge, there's much more complexity there, right? The underlying Linux OS, complexities can be exploited by attackers to compromise all the containers on a host OS. So if you do own the host OS, you can in turn compromise the containers on that host OS, right? You can have runtime compromise, where when the container's running, right, code within it can be used to take over the container, right, or can take over the management plane and own the container. You can have vulnerabilities or misconfiguration of your container. So these are all challenges that need to be addressed. Secure software development. Where is the code coming from, right? If you don't know where your code is coming from, then how do you trust what's running in your container? You have to know what the source is of the code that's pushing to that container platform, right? So what's the source? Log management. With a container platform, we now have a big data problem, right? How do you view and manage logs across thousands or tens of thousands of containers? And then last, orchestration. Actually, it's not last, there's another slide. Infrastructure now runs as code. You've got Puppet, you've got Chef, you've got Ansible, and other tools that now act as the orchestration engines of our data center, where software developers, not infrastructure staff, are running the data center, right? File system compromise, right? You can have microservices in the container that could be compromised by an attacker. So if the microservice is compromised, you have that exfil potential to go east-west, right? From your container, your container's popped, I can go across laterally to other containers, or go north-south, right? Which leads us to networking. A compromised container could lead to that lateral movement, north, south, east, or west, right? And then the runtime compromise or privilege escalation, where an attacker can modify that microservice in the container, which compromises the application or the container itself. So these are, at a high level, some challenges that we all need to consider when looking at microservices and containers. Well, with challenges, there have to be best practices or solutions that are considered. So let's talk about what those best practices should be. So for that increased attack surface, employ micro VMs or just enough VMs. There is no need to have a OS that has every binary and library available to it. Just have just enough binaries and libraries on that host OS for the application upon which it's supposed to run needs to function. There's no need to have everything enabled. The higher your attack surface, the more binaries and libraries you have, the more things that a attacker has to take control of your machine unbeknownst to you, right? Monitor your containers at runtime, right? And do real-time scans for vulnerabilities and misconfigurations and remediate those misconfigurations. There are things that when you deploy to production or deploy to your environment, whatever environment it is, dev, test, QA, production, or however many environments you have, where changes could occur. Unless you're monitoring them, somebody else is, and they're waiting for you not to look. So make sure you're monitoring your container infrastructure. Secure software development. Whitelist or blacklist your containers. Which containers are authorized to run on this host OS and which ones are not, right? If you don't know where your containers are going to run or not supposed to run, somebody else will. Establish a secure container registry. Remember we said, where's your code coming from? Know that this is the source of truth for all your code, and this is where your code repository is authorized to push to these containers. And then sign those containers and code with, at minimum, an MD5 checksum, right? Log management. Centralize your container logs, including developer actions. It's not enough to just know, hey, here's all the logs I have for the containers and the actions that were taken against it. In a true DevOps world, you've got developers serving as operators as well that are pushing code to all of these different environments, right? You need to know who did what where so you can do the correlation between the developer actions and what's going on within your container infrastructure, right? And then orchestration. So you now have a very large, complex environment with containers and microservices, which adds a lot of flexibility and scalability and benefits, but you need to be able to manage that. So leverage a container management platform to manage containers across environments and across clouds. Because you now have the ability to do efficient restart and scale up and scale out, you need to have a container management platform that can manage all of those across those environments. So for file system compromise, ensure your file system is read-only, right? If your servers are stateless, why do you need to write to your server, right? Make sure the file system is read-only. So then you can't go and pop the file system. And again, back to second, treat the servers as stateless, right? In a true stateless architecture, you're not worried about patching the servers, right? What do if it's stateless? Because it's containers and you can restart containers in a fraction of a second, you don't patch the server, you throw it away and you start to deploy a new one, right? In this architecture, because the servers are stateless, right? So the application never goes down because you can move those containers across your architecture. You're refreshing the server infrastructure. So that increases your security boundaries because your servers are read-only, right? And you're just rebuilding them on demand. From a networking perspective, ensure the containers that you have deployed only talk to other approved application containers, right? Monitor your east-west traffic, right? And even north-south if you're leaving that host so that you know what container can talk to what other containers, right? And then monitor that traffic. For runtime compromise or privilege escalation, set a filter on your Linux kernel to prevent privilege escalation, right? And implement whitelists as to who can talk to what, when, and where, right? And then set up anomaly detection based on a deviation from a known baseline. You need to know what your baseline is. This is my baseline. This is where we started. We need to do anomaly detection based off of a known good, right? To prevent that remote code execution. So this is our known good. Are there changes to our known good? If there's remote code execution, we can address that, right? For microservices, you need to decompose applications into microservices correctly so they do what? One thing well, right? It's not trying to get a microservice to do many things. Get a microservice, when you're architecting it and designing it, to do one thing well, right? This drives development of secure code. It's all about having these loosely coupled, independent processes, right, from an architectural approach. And then, so when you think about that from a monolithic code perspective with 1,000 DLLs, they need to be decomposed into 1,000 microservices or more, right? Which will make it inherently more secure and maintainable, because you're now just making sure that each one of those microservices can just do the one thing. You're upgrading just that one piece of that code as opposed to checking to see what all the dependencies are between all of these different components, right? So by designing your architecture correctly so they do one thing well, you now have the ability to do continuous integration and deployment. And then ensure that just because they can do one thing well, and there's a lot more microservices, you are using interface-driven development. You need well-defined REST APIs to ensure the microservices talk consistently to each other. Do not build the Tower of Babel, right? Where you don't know what language you're talking to the other microservices in. Well-defined REST APIs across your microservices architecture. So, back to standards. So we need some sort of baseline to have this conversation around best practices for containers and microservices. So NIST and CSA have joined forces to define these best practices for containers and microservices. So it is based off of SB 800-180, which is, again, that NIST definition of microservices and containers as a foundation, again, level set. So the charter for this group was to aggregate and document application containers and microservices use cases, research and document the challenges of implementing and managing containers and services, look at both process-based and endpoint-based threats to deployment, container deployments and stacks, and then provide those security recommendations for adopting these practices. So we came up with 2 deliverables. The first deliverable was documenting the challenges of implementing and managing the containers and microservices, focusing on those deployment and runtime security threats, and then the recommendations for mitigating these identified deployment and runtime security threats to containers and microservices. So, so our progress, we developed a use case template that, and this started last year, of, here's the use cases that we need to evaluate, create a methodology to score the challenges. We came up with something like 120-ish some odd challenges, whittled that down to about 108 challenges, and then scored them across a number of different vectors to determine which challenges were the most relevant in a container microservices architecture based on a predefined set of questions and criteria that the team leveraged. So we had a team of about 30 folks from all across industry and government, from Salesforce to the U.S. Army Aberdeen Proving Grounds to startups in Silicon Valley. It was a consortium of folks that helped develop this guidance. And then we identified best practices to secure these containers and microservices. So path forward, the documents have been written. They're currently in NIST internal review, and they will be published for public comment shortly. So we're going to give you a preview of what these documents are, along with the document numbers. So if you'd like to take note of the numbers, you can see what's going to be coming out from NIST shortly in this regard. So this will be the first document. This is NIST IR 8198 is the number for this document that will be released. And this is the challenges document in securing containers and microservices. So in IR 8198, we used a document as another foundational principle for this, which is NIST 800-160, which is the System Security Engineering document for trustworthy computing systems. Highly recommend taking a look at that. That's a system engineering approach for building trustworthy computing systems. That was a guiding document for the development of this artifact. One of the other things that we did is when we created this use case template, we looked at it across 3 lenses. We looked at it through the lens of a developer, an operator, and an architect. Because each one of those views, even if it's the same person, is going to have a different viewpoint on what the challenge might be. So by looking at it through these different views, we can look at this challenge, see the different viewpoints from these different roles that even a single person could play, and then how you can derive best practices from the same, right? So this is one of the use cases. So this is code promotion across environments. Apologies for the text, a little hard to read. Slides are available afterwards per the keynote, so they'll be available on sector.ca's website, I believe. So this is the use case of how do you move code across environments. Both developers and operators need to be equally engaged in that code promotion path across container environments, right? Developers need to be able to push code across those environments without the need for operator interaction, right? So from a developer perspective, right, where is the code coming from, right? Who's got the keys in terms of key management and certificates for signing the containers and the code, right? So there are multiple parties potentially and multiple certificates that are involved and certificate owners, right? So you could, if these are not addressed, have application version mismatches, or code is not pushed correctly to all of these different environments, what code goes where, or you could have images that are tampered with because they weren't signed by somebody else or an untrusted source, from a developer standpoint. From an operator perspective, right, developers need this easy and safe access to cryptographically verified container images, right, which is a challenge because you have to manage as an operator one or more trusted code repositories, right, depending on the number of environments, right? So you also need to ensure from an operator perspective the same version of the application is run across the multiple environments. Mood lighting. And that can be a challenge across multiple parties, sites or deployment paths, right? So with that, with challenges come best practices. So this will be SB 800-198 was this document. So this is secure development operations, best practices in securing containers and microservices. And so this will look at the same use case, same challenge through a best practices lens, right? So again, built off of SP 800-160 and then 180 from a definitional standpoint, same three lenses, right? So best practices here. Developers should establish a root of trust, right? If you don't know what your root of trust is as a developer, your adversary does. So establish a known good root of trust, right? And the developer needs the ability to digitally sign and provide that signature for the code as you push across these environments. Second, operators should leverage a container management platform to securely move images across environments, right? Again, being able to manage the code across this code promotion path from a best practices point of view is something that operators should consider. And again, these are the different viewpoints. And this is just one of the use cases. There are multiple use cases in these documents. There's something like about 100 pages of best practices and whatnot. So this is really just a sampling of what's in there. But again, it gives you an idea of the type of work and research that went into creating these best practices. So we're not done. So the definition here and what we created here from a NIST perspective is a starting point for future work. So CSA is going to take that work, build on it, and create an implementation guidance document with vendor-specific implementation guidance with unique security issues and concerns that are addressed from containers, host hardening and security recommendations that are vendor-specific, incorporating the great vendor guidance that are already there, inviting the vendors that are already out there, be part of the team to create this, right? And then ensuring that we've defined these microservices secure development standards and guidance, which leads us to the second objective, a microservice implementations guidance document for best practices on implementing a microservices architecture for cloud-native applications, and best practices for decomposing monolithic applications into microservices. So with that said, building documents like this cannot be done in a vacuum. It has to be done with a community. So how do you get involved, you ask? I'm glad you asked. So we would invite you to join our efforts to help define these best practices, because really understanding the challenges from each of your unique vectors, each of your unique point of views, is going to add considerable value. So email us. The co-chair of this group, both on the NIST and CSA side, is Andrew Wild. He's the CISO of the QTS data centers. So just email us and we'll get you connected with how to get involved with this effort. So with that, I want to leave you with a closing thought and then open it up for questions so we have an opportunity for a dialogue. So closing thought. How many folks here enjoy TV, movies, watch a play, whatnot? Okay, I was about to say, I'm like, there's some people actually do enjoy movies and TV. You're being a little shy. But it's morning. It's the first session after keynote. So the reality is, we all enjoy some form of theater and entertainment, right? So usually, not usually, stage actors, when you come up on stage, they have, 3 walls. They have a wall on one side with a door they come in and out of, typically a backdrop with some windows, and a side wall with windows. And their actions are all orchestrated by a developer or a developer, a director, right? So yeah, you got the application developer on the mind. By a director. So the director is orchestrating the activities of the stage actors on stage. There is an understanding between the director and the actors on stage that the stage actors are not to make eye contact with the members of the audience or the camera. Why? Because if they make eye contact with the members of the audience or the camera, the illusion is broken between that fact that you're watching them and they now know you're watching them, you know that they're watching you, right? So the illusion of what they're trying to portray is completely broken, right? You're no longer watching them from the safety of your glass. It's called breaking the fourth wall, right? You're no longer isolated from them because that fourth wall has been broken, right? So let's translate that into our parlance. As information security professionals, you guys are the directors. Your data is what's on stage, right? So our job as information security professionals is to find the right balance between security, privacy, and functionality, leveraging a data-centric approach to defend the fourth wall. So with that, thank you guys for your time, and we'll open up for questions.
Thank you. At least I understood you to say that we should whitelist or blacklist where a container could run. I'm wondering, how practically do you do that?
So, practically speaking, container management platform, right? The container management platform, that whatever platform you choose to use, would be the practical way in which you would whitelist or blacklist your application. So, without being vendor specific, you would pick a platform and then say, all right, this is what can run in this environment, right? This is what could not run in this environment. Sir.
Thank you. You mentioned earlier on in the presentation about the risk assessment of the data that these containers are actually going to be accessing. How are you doing that? Is that quantified risk or qualified risk? Because typically the way the data is assessed is not statistically based. So in some cases you can do some things to de-identify the data, but you really have no idea whether the risk is higher or lower after the de-identification, and you're still going to be using the containers to access that data.
Right, so it comes back to first, you have to first understand the value of the information, right? That's kind of the first step, right? And remember that, understand, right? And then, so if you don't know the value before it even gets in the container, it's very hard to then do a risk analysis of that data. So the first step before it even gets in the container is what's the value of the data that's going to go in there, right? So that's the first step in that risk analysis. Understand the value of the information. Then you can decompose, how that data should be protected within said containers. And then the risk analysis can happen. So you need to do it in that understand, decompose, then monitor approach, as opposed to try to do it from monitor and go backwards. Because if you go from monitor and go backwards, you'll fail, because you won't know what the value is. So you're trying to identify and quantify risk, but if you don't know what the value is before it gets there, it's chicken and the egg, right? So understand the value first, then decompose, then monitor. Sir.
Yeah, sure. Is there a plan to build a standard or a guideline on how to log security events inside a container or a microservice? Because right now it's kind of everyone doing it its own way. It's almost impossible to reconciliate the information in a standardized way. Is that something one of those standards would address eventually and could be implemented by container providers and applications and so forth?
Yes, great question. So in that vein, there's two things. So I'll speak to one thing. So one piece of that is the NIST guidance right now was non-vendor specific, right? The CSA guidance that's going to follow on to that will be vendor specific and provide more detailed guidance to address issues specific to that. Because there are so many different ways in which those logs can be written. How do you make sense of all the different logs, as you just stated, that come in? It's that big data problem that we mentioned earlier, right? How do you normalize the information and the events that are coming in to your log management platform? Yes, so the CSA effort will provide some guidance around how those logs, in a standardized structured format for how those logs should be written. I'll also put a teaser out for another NIST project that we're working on, right? So how many folks here are familiar with SCAP? Security Content Automation Protocol, right? How many folks are familiar with the multitude of standards upon which your information systems have to be certified and accredited against, right? We have to, you don't just accredit against 1 or 2 or 3 or whatnot. You got to accredit against, however many that your organization is required to accredit against. And some of these controls are mutually exclusive. So I know I'm going off track for a second, but this is kind of a NIST project that you'll hear more about next year. So there needs to be a way to normalize these security controls in a way that is XML or JSON based, where you can write an XML query or a JSON query against a framework and then provide an output as to whether or not that control is implemented. We call that the Open Security Controls Assessment Language, OSCAL. That is a project that we're currently working on. You'll hear a lot more about that next year. So I know I went sideways for a second. If you want to hear more about that, we can talk about it afterwards. But that's something that is an ongoing challenge that, since we talked about logs, that is something that needs to be normalized as well. So, any other questions?
Well,
sorry, if you can wait for the
let's just
mic.
use the microphone.
Given the fact that you said the guidance for that wouldn't be out till next year, and yet we have pressure this year to go containerize our applications, there's a gap, and that's gonna mean higher risk from a security standpoint.
Mm-hmm. Yeah. So
how do we bridge that gap?
So the first step is the NIST documents that I just referenced will be published shortly. So that will provide that initial guidance from a NIST perspective that CSA also worked on, some of the 30 some odd folks that we just mentioned. That's the first step, right? The next step to that is the CSA guidance that we developed that builds on that, right? While we receive the public comments on the first piece of documents that we wrote, the 100 some odd pages of documents that are coming out. So that's the first step, and that should be shortly, right? We were hoping it would already be out by now, but the government, it takes a little bit of time to work its way through the approval process. So apologies for that, but as soon as it's out, it'll be publicly available. You've got the 2 numbers to look for, so as soon as those numbers come out, they're free, they're publicly available, you can use it to start that process. The next will be the CSA artifacts. The OSCAL project is a wholly different project. I just brought it up because of the need to standardize controls and whatnot. That'll be coming out around April-ish timeframe of next year. So
I'll ask one. How come the standard didn't cover role-based access controls? Seems like it should be something standard in the specification.
we do address RBAC. We didn't put every challenge and every best practice up here. So like I said, there's something like 108 challenges and associated best practices. I gave you one. So
Gotcha.
yeah, so there's a bunch more. So they were like, hey, why don't you get this? Why don't you get that? So that was 2 pages out of a 100 some odd page document. So there is more. So and I will also say this: there's going to be a lot of things in there that have not been addressed. And the reality is, and we as a team, we struggled with that. And that's to your point, sir, which is, where do you draw the line to provide some guidance versus providing no guidance? Because we were consistently struggling with, what about this challenge? What about that challenge? What about all these different things? You have to draw the line somewhere, publish something, and then continually update it, right? So that you're adding new challenges, adding new best practices.
Very agile.
Exactly. That's exactly right. So there will be things that are missed, but that's by definition, just to start.
So if you have, let's say, around 1,000 microservices and you feel one of them is compromised, is there a quick way you can start nailing down where the breach is?
So if one microservice is compromised, right, so the best way to isolate it is, A, limit your lateral movement, right? So if you have anomaly detection based off of a known baseline, right? So say, here's my baseline, right? And you're doing anomaly detection of, here are patterns of behavior of a microservice that is a deviation from this known baseline. You now know where to look to limit that lateral movement. That's how you address that. You have to have the anomaly direction, and again, based off that known baseline. That's how you do it. And there's vendors that do that, but I don't want to publicly endorse a vendor. So we are not that vendor. I'll also say that. Thank you again for your time. Appreciate it. And happy to answer any questions afterwards.